Okay guys, today we're going to be talking about surface area. This is the introductory lesson, and just like before when we talked about area, perimeter, and volume, I want to relate this to something that's a real world concept. And when you think of surface area, you want to think of wrapping a present. It's a perfect time of year to think about that. So how much wrapping paper is it going to take to cover every side of a box? We're not worried about the volume. We're not worried about what goes in the box. We're just worried about covering the outside. And just like the name says, we're talking about area, the area of the outside. The only difference is this is a three-dimensional shape now. So now we have multiple sides of area that we have to combine. Before we were dealing with only two-dimensional shapes, so we only had to worry about one side. A 6 by 7 shape would have had an area of 42 centimeters in this case. But now we've got 6 sides on this box, cube actually. So that's the way you can think about it. That's one way to think about it, is that you have 6 sides on this box, and they happen to be 3 different dimensions. You have 6 centimeters long by 4 centimeters wide by 7 centimeters tall. So if you think about this and break it down into the different components, it makes it a little bit easier. This is where colored pencils is going to help out. If you take and shade this front side, you can see that it is 6 centimeters long and it's 7 centimeters tall. This 4 doesn't have anything to do with this surface that we're working on right here. So if I do that, then I know 6 times 7 is 42 centimeters, and I have 2 of those sides. I have a front and I have a back side, which we cannot see. So I'm going to make a little chart over here, and I've got it written down. 2 sides at 6 by 7, which is 2 times 42, which is 84. So 84 centimeters to cover this side and the back side, which I cannot see. Now if I look at this side of the box is 4 centimeters wide by 7 centimeters tall. 7 times 4 is 28. I have this side, and I also have the opposite side. So 2 times 28 is 56. And I've just calculated that down here. So I've got 84 for the front and the back plus 56 for the 2 sides. Now I have to calculate the top and the bottom. So if I look at the top, you can't see the bottom, but I do know that it's 6 centimeters wide and it is 6 centimeters long, 4 centimeters wide. So I've got a 6 by 4 box on the top. 6 times 4 is 24. I have a top and I have a bottom. They're both the same. So I've got 6 times 4, or 2 times 24, which is 48. So then I take all of those partial products and I add them up. I had 84 for these 2 sides, 56 for these 2 sides, and 48 for these 2 sides. And when I add them up, I get 188 centimeters cubed. I'm sorry, squared. It's squared. Even though this is a cube we're dealing with, it's squared because it is surface area. Remember, anytime we're messing with area, it's going to be a squared answer because I am multiplying one dimension by another. I'm multiplying 2 numbers together, not 3 as we did with volume. Now, the other way to do this is a little more complex. Some people can see this. Some will have a harder time with this. Basically, if I took this box and I cut it where all the pieces were still connected by one side, this is basically what it would look like. This is called a net. Different shapes have different nets, and as I said, some people can conceptually see this. It's easy for them to see. Others cannot. It works better to deal with the cube and to shade those with the colored pencils. Either way, it doesn't matter to me. But what you have to realize is that the dimensions are going to be the same. I've got one side of the box that is 6 by 7, which would be the front. Right next to it would be this side, which is 7 by 4. And then on the back side of the cube would be another 6 by 7 box. And then finally, this last side over here would be the 7 by 4 side that's right here. This would be the bottom flap, this would be the top, and it would just fold in. So as you fold those in, it just all goes together in a cube. A little bit difficult to see this. It may work for you, it may not. We'll practice those in class. We'll try building some nets and figuring out surface area. But that's surface area in a nutshell. We will work on this through winter break, and